All right, here we go. Part 2 for rational exponents. So this part's going to be very similar to the first part. You're just adding one additional step, okay? So I'm going to go ahead and write those steps down here so we can just continually refer back to them so you can see that that's just what we're doing every single time. So anytime you have one with the actually has a numerator, that numerator is going to be your exponent. Okay, so the first step you need to do, just like what we did in part 1, you're going to take the root. Okay, and I didn't put square root or anything like that because it can change depending on the problem. Okay, so just know that that could be square root, cubed root, fourth root, fifth, sixth, seventh, whatever. Okay, and then the next step, whatever you get from step 1, you're going to then take the exponent. All right, so I'm just going to keep these notes down here, and you can see that as we solve these out, we're going to use each one of those steps every single time. So if I put a little 1 or a little 2 in a circle, these are the steps that I'm referring to. Okay, so I would take a second and write this down so you can remember it if you have to look back at these notes. All right, so let's look at number 1. So we have 14 to the 3/2 power. Okay, so I know that my numerator is going to be my exponent, and then I know that my denominator, just like in the last one, that's my root, just like in the other one. Okay, what you're used to in part 1 was that this was just a 1. Well, we didn't have. If you take anything to the first power, it's always going to be the same thing, so you don't even have to show that step. But now we're going to be taking it to the third power, squared, third power, and so on. Okay, so let's rewrite the problem. Make that any smaller. Okay, so we have the square root of 14. Okay, so the base to the root. And then we're going to take that and we're going to square it. We're going to cube it, I'm sorry. Okay, so let's refer back to our steps. We're going to take the root. Okay, so that's basically what's going to be inside of your parentheses. So the square root of 14. What two numbers can we multiply by itself to give you 14? There isn't one, so that can't be simplified anymore. So this is the simplified form. Can't simplify it any further. Okay? Easy. Next, we have x to the 5 times x to the 3 halves. Okay? Can't remember what color I used in this one. Red. All right, so just like in part 1, this 3 halves is only dealing with my x. Okay? So we're just going to bring down the 5, and that's going to be times. The denominator is going to be my root. The numerator is going to be my exponent. So that's going to be times square root of x raised to the third power. Now again, that can't be simplified any further. So that would be the final answer. Now if we could simplify it further, if we had a number here, let's say 16. Okay, the square root of 16 is 4. 4 cubed would be 4 times 4, 16 times 4, 64 times 5. Okay, so if we knew what x was, there's a possibility we could simplify it further. All right, next we have y to the 2/3, and then we're multiplying all that times 17. So again, this is its own thing, so we'll just bring down the 17. My denominator is my root, so that's going to be the cubed root of y. You're going to take all that and square it. Just like in the last one, we don't know what y is, so we can't simplify this one any further. Okay. Next. All right, we have 49 to the 3 halves, okay? So again, my denominator is my root. My numerator is my exponent. So that's going to be the square root of 49 cubed. Okay, now we can finally actually use these steps down here. Okay, step 1, take the root. Okay, so we're going to take the square root of 49. Okay, what two numbers can we multiply by itself to give us 49? It's 7. So now we have 7 cubed. All right, then we're going to take the exponent. 7 cubed. 7 times 7 is 21. 21 times 7 is 147. I did something. Nope, backwards. 7 times 7 is 49. 49 times 7 is 343. Yep. Okay. Yeah, so that's how you do that one. So that would be its simplified answer. So we could actually solve that one because at this number, we could actually take the square root of it. Next, we have 25 to the 3 halves, okay? So denominator is our root, numerator is our exponent. So we have square root of 25 cubed. All right, step 1, do the square root. What times what gives me 25? It's 5. Then we have 5 cubed. 5 times 5 is 25. Times 5 is 125. Okay, last one on this row, and then I'll start moving quicker through the other ones. So hopefully we've kind of picked up on the steps. All right, so we have 27 to the 2/3. Remember, our denominator is our root. So we have the cubed root of 27, and we are going to square it. All right, step 1, solve for the root. What can we multiply by itself 3 times to give us 27? It's 3. Then we take the exponent, so 3 squared equals 9. And that is how you do it. Now again, if you have access to a calculator, by all means, use it. But you do need to know these steps in case you are ever in a situation where you can't have a calculator. Okay? Next one, we have x to the 4/3. Obviously, we're not going to be able to simplify this one because it's an x, but we can still write it in radical form. All right, and remember, radical form just means that it's in a root. All right, so x to the 4/3, our denominator is our root, so it's going to be x to the cubed root of x, and then we're taking that to the 4th power. Can't simplify it anymore because we don't know what x is. Next, this 5 halves is not with all of it. You would know the 5 halves is with all of it is if all of this was in parentheses. Then you would know, just like in our last unit, you would have to distribute it. But because it's not all in parentheses, then that 5 halves is just with the b. Okay, so we can just bring that 19a down, and then we have b to the 5 halves. So the denominator is my root. That's the square root of b. And then we're going to take that to the 5th power. Can't simplify it anymore because we don't know what a is, we don't know what b is. All right, this one starts in radical form as a square root, or a 4th root actually, and it wants us to write it as an exponent. It wants to write it in exponential form. Okay, so we know our root is always going to be our denominator, and our exponent is going to be our numerator. All right, so we have our base of y, and it'll be to the 3/4. We can't simplify it anymore because we don't know what y is. Next, 64 to the 2/3. Our denominator is our root. Numerator is our exponent. So we have the cubed root, 64 squared, referring back to my steps down here. Cubed root of 64, what can we multiply by itself 4 times to give us 64? That answer is 4. Just kidding. 8. Nope. It's 4. 4 times 4 is 8. 8 times 4 is 32. 8 times 4 is 32. Oh, no. It's 4. 4 times 4 is 16. Yeah, it's 4. Okay, so then we do 4 squared because we took the exponent. 4 squared is 16. I'm struggling right now. Sorry, guys. Yeah. All right, so we can multiply 4 by itself 3 times, and that gives us 64. And then we take the exponent. 4 squared is 16. Sorry about that. That one may have been confusing. Next, our denominator is our root, numerator is our exponent. So we have the square root of 100 cubed. Okay, we do the root first. So what times what gives us 100? It's 10. Okay, then we take 10 and we cube it. So 10 to the third power is 1,000. All right, last one for this row. All right, we know that the root is always going to be the denominator, and the exponent is the numerator. All right, so we have 16 to the 3/4 power. Okay, but it's easier, honestly, to solve it in its original form, if you were to ask me. But that's how you'd write it as an exponent. Okay, so again, we do the root first. So what can we multiply by itself 4 times to get 16? It would be 2. It would be 2. And then we take the exponent. So 2 to the third power is going to be 8. All right, last row, and then we are finished with week 2, day 1. Okay, next. So the square root is understood to be 2, even though it didn't have a number there to begin with. If there's not a number there, it's understood to be 2. So we know our root is our denominator, and our exponent, and our exponent is our numerator. Okay, so that would be 12n to the, oops, I didn't write that in. 12n to the 3/2 power. All right, and we can't simplify that anymore because we don't know what n is. All right, so our just kidding, our root is our denominator. That's our numerator. And again, just like in my last week's videos, if you feel confident in, after maybe the first few, pause the video, work ahead, and then check your answers, okay? I highly recommend that because it's really the only additional practice that you get to see if you know how to do it. Okay, so that's going to be our denominator, so it's going to be b to the 2/3. Okay, and since we don't know what b is, that would be its simplest form. All right, so this is the square root of 37 to the 5th power. All right, so always do the root first. There is not a number that we can multiply by itself to give us 37. So that would just stay the same. So really the only thing we can do to simplify it is just to change it to exponential form. So we know the root's going to be our denominator. And we know that that's going to be our numerator. So that's going to be 37 to the 5/2. All right, next. I really like this question because it's going to tie into something that we talked about earlier on in the last unit. All right, so we have the square root of 144 squared. Okay, so step 1 is we are going to do our square root. So we have the square root of 144 squared. All right, so what can we multiply by itself to give us 144? It would be 12. All right, and then we're going to do 12 squared, so 12 times 12 would be 144. All right, so when we think of an inverse of numbers, when we think of like multiplication, the inverse is division. When we think about addition, the inverse is subtraction. When you're thinking about exponents, its inverse is a square root. And when you're thinking of square roots, its inverse is its exponent. So when you have the square root and you have a squared, essentially they're just going to cancel each other out and you're left with whatever this number is. And you can see that right here. Okay. I'm going to skip this next one real quick and do this one. Okay. So again, we have the square root of 64 squared. Okay, well, we have a square root and a squared. Those are just going to cancel out, and it's going to equal 64. Okay, and if you want to double check the square root of 64, what can we multiply by itself to give us 64? 8. Then we do 8 squared, and that's 64. So anytime you have, it has to be the square root, okay, and a squared in order to cancel. Or it would have to be a cubed root and a cubed, okay, in order for them to cancel. So we couldn't just cancel this one out here. All right, so let's do this last one, and then we are finished with day 1. All right, so we are going to do the inside of this first. So what can we multiply by itself 3 times to get 125? It would be 5 squared would be 25. All right, and that is the end of rational exponents. I know that's kind of a lot, but now we're going to get deeper into this lesson, and then you're going to be applying these different skills in there, okay? So get it done, make your notes all nice and pretty for me. Make sure, I would prefer if you submitted them onto Google Classroom, but if that's an issue, send me an email with them attached, send me a remind with them attached, or whatever works easiest for you. All right, thanks guys, see y'all.